Hello students, today we are delivering one more lecture on problem set, and today I will try to find, I will try to locate, not locate, I will try to find the moment of inertia in different cases. So let's start with first problem. First, look at this. There is a rod of length L and its mass is m. We have to find moment of inertia about this axis. An axis passing through the end of the rod and perpendicular to the length of the rod. We have to find this I prime. I see we should know, because you see the moment of inertia of the rod about the center of mass axis perpendicular to the length of the rod, that we are supposed to know, and I have already explained that, and I have given you the all the values about the center of mass. So the moment of inertia of the rod about the center of mass axis, normal and perpendicular to the length of the rod, that is given to be this 1/12 ml square. Now, what's the moment of inertia of the same rod about the end axis? I mean the axis passing through the end of the rod and perpendicular to the length of the rod. So which formula we are going to use here? If you remember the last lecture, earlier lectures on rotational dynamics, I explained to you parallel axis theorem. The parallel axis theorem was I moment of inertia about any axis, maybe this or maybe any other axis, is IC plus mh square. This was the formula, where IC is the moment of inertia about the center of mass axis, m is the mass of the object, and h is the distance between the two axes. I mean the center of mass axis and the new axis, the axis about which you have to find the moment of inertia, the new one. So here it is I prime here. So it is what's IC, and we have to find the answer in terms of IC, or in terms of this ml square. So it is 1/12 ml square plus m, mass of this rod, h square, what is the distance between the two axes? That is L/2. It is L/2 whole square, right? So it is I prime 1/12 ml square plus m L square by 4. So it's I prime is equal to 12 is LCM, it is ml square plus 3m L square, that is 4m L square by 12 is equal to 1/3 m L square. So I prime, we got the value in terms of ml square. Suppose we need to get the value in case of IC. How many ICs? I prime is how many ICs? So if we are to find the moment of inertia of the rod about the end axis in terms of IC. So what should I do here? So it's 1/3. What is the ml square here? Ml square, that is 12 IC. From here, ml square is 12 IC. So it is 3, 4. It is 4 times IC. So moment of inertia about the end axis is 4 times the moment of inertia about the center of mass axis. This was problem number first. Now let me go to the problem number second. And this is the second problem. What is the second problem here? Have a look. You have a rod and you know it is moment of inertia about the center of mass axis. We know that. अगर आपके पास rod है, so if I ask you what is the moment of inertia about the center of mass axis, the answer is obviously 1/12 ml square. But now what I do? I bend the rod through the middle, through the midpoint. I bend the rod into two parts, right? This part is L/2, this part is L/2, and this part of the rod is m/2, and this part of the rod is m/2, because the total mass of the rod is m. I want to find the moment of inertia about the same axis. And when I bend the rod, the angle between the two parts is now 60. And the angle between the axis and one of the rod pieces is 30. This is 30, The whole angle is 60. We have to find the moment of inertia about this vertical axis. But remember one point, these two rod pieces and the axis are in the same plane. ऐसा नहीं कि the axis is like this, perpendicular to the length of the rod. No, the two rod pieces and this axis are in the same plane. So what to do? How to solve this problem? See what I will do. ये rod pieces है ना, ये वाले. These are the two rod pieces, right? It is L by 2. It is L by 2. Mass इसका M by 2 और इसका भी mass M by 2. और देखा जाए तो ये 30 degrees है with the axis. One of the rod pieces makes 30 degrees with the axis. What I will do? You see what I am going to do? I will put this rod piece into two components, hypothetically, into two components. One component is in this direction and one component is in this direction. जो ये component है, it is L by 2 cos 30. जो ये component is L by 2 sin 30. मैंने इसके दो pieces कर दिए, एक piece ऐसे और दूसरा piece ऐसे. इसी तरह से इसके भी दो pieces, एक piece ऐसे आएगा, दूसरा piece ऐसा, vertically. तो इसका भी दो pieces, एक piece ऐसे आएगा, L by 2 sin 30, और दूसरा piece उसका भी vertical आएगा, वो भी आएगा L by 2 cos 30. इसके दो pieces यूं और यूं, और इसके भी दो पीस ऐसे और ऐसे. जो ये दो पीसेस हो गए वर्टिकली अलोंग द एक्सिस, इनका कंट्रीब्यूशन जीरो होगा. इन दो का बिकॉज दे आर अलाइंड अलोंग द एक्सिस. ये जो दो वर्टिकल पीसेस है वो एक्सिस के अलोंग ही है, तो उनका कंट्रीब्यूशन मोमेंट ऑफ इनर्शिया का जीरो होगा. अगर कंट्रीब्यूशन होगा वो इस पीस और इस पीस का होगा, बिकॉज दीज पीसेस आर समवेयर अवे फ्रॉम द एक्सिस. बट ये जो दो पीस है they will go along the axis. तो moment of inertia जो मुझे मिलेगा वो इसका मिलेगा. कितना? 1/3, because the axis passes through its end, through the end of one of the pieces. इस पीस के एंड के थ्रू जा रहा है, तो वो हमें पता है that is 1/3 ml square. मगर which m and which l? m by 2, because इसका मास m by 2 है, m by 2, और which l? That is not L length, that is L by 2 sin 30 whole square. ये. So I is equal to 1/3 m by 2 L by 2 sin 30 whole square. हुआ इस पीस का, लेकिन इस पीस का ऐड करना पड़ेगा. So 2 times. तो ये होगा आंसर. I is equal to 1/3 m by 2 L square by 4. ये वाला sin theta is 1/2, that will become square 1/4 again. वो होगा 2 and 2 cancels. I is equal to 1/48, 4, 4 and 3, 48 ml square. That is the answer. So this rod, when it bends into pieces and making angle 60 with each other, we have to find this moment of inertia about this axis. What we did, इसके दो pieces कर दिए, यहाँ से और यहाँ से, और यहाँ से और यहाँ से, इसके भी दो pieces यहाँ से और यहाँ से. ये दो pieces का moment of inertia तो होगा नहीं, because they are aligned along the axis. इन दो का है, therefore इन दो का हमने निकाल कर इस तरह से दिया. Okay, third problem. This is the third problem. Here it's a ring, and it is an axis passing through the diameter of the ring, right? There is one more axis which is parallel to the diameter axis, and we have to find the moment of inertia of this ring about this axis. And this axis is how much away from the axis of the ring, that is r, where r is also the radius of the ring. So which formula we are going to use here? We are going to use formula here, parallel axis theorem. First of all, we must know the moment of inertia of the ring about the diameter axis. Generally, we know the moment of inertia of the ring about the center of mass axis passing through the perpendicular to the plane of the ring. That is mr square. But what's the moment of inertia of the ring about the diameter axis? That we have already done. About the diameter, it is 1/2 mr square. So moment of inertia about this diameter ring, that is IC, is equal to 1 by 2 mr square. It is also center of mass axis, because this axis also passes through the center of mass, but it is not perpendicular to the plane of the ring. It is passing through the, it is not perpendicular to the plane of the ring, it is passing through the plane of the ring, not perpendicular, through the plane of the ring, through the diameter and passing through the center. And it is moment of inertia, as you must know, it is 1 by 2 mr square. Ring ka. So what formula we use? This axis and this axis are parallel, and we will get moment of inertia about PQ axis is equal to moment of inertia about the center of mass axis plus mh square. Parallel axis theorem we use. So it is IPQ, which we have to find. Moment of inertia about PQ axis is equal to IC, that is 1 by 2 mr square plus m. What is the h distance between two axes? This one. That is r again, r square. So it's IPQ is equal to, अगर इनको ऐड किया जाए तो 3 by 2 mr square. That is the answer. Fourth one. Let's talk about this problem. It's the axis, y axis, y prime, vertical axis. We have a mass point which is at the center, which is at the center of the coordinate system, at the origin of the coordinate system. One more mass here, mass here. These are discrete masses, and to find the moment of inertia of a system of discrete masses, anyway, quite easy. And which formula we are going to use here to find the moment of inertia of all these 4 particle system about this y-axis, y prime axis, this one, right? So these are the 2 particles here, 1 particle here, 1 particle here, and all the particles जो है इनका हमें coordinates दिया हुआ है. So we use the formula moment of inertia is equal to summation of mr square, where r is the shortest distance of the mass point from the axis. ये r जो है ये है distance from the axis of this mass m. So I equal to, what is the mr square for this? M is m, because its mass is m. What is r? How much away it is from this axis on which it lies? 0. Plus, summation means plus. Second m. Okay, let's take this m. M. How much away it is from the axis? This one, y axis. That is, it is coordinate, y coordinate, that is a. Is x coordinate. It is its x coordinate is a. So it is this distance. It is the x coordinate. ये y axis से कितना दूर है? That is x coordinate a. तो ये दूरी ये a है. ठीक? तो a square plus m. This one. How much away it's from the y axis? How much away is from the y axis? Again, it must be plus a, it must be minus a. ये x axis, y axis से a दूर है. A, this one. So it's again a square plus m, ये वाला. How much away it's from the x axis? How much away it's from the y axis? This distance? 2a, simply 2a square. So I equal to, okay, this is 0 plus ma square plus ma square plus 4ma square, right? So I is equal to 4, 5 and 6 ma square. This is the answer. Let me go to the 5th problem. Okay. This is 5th problem. We have 2 rings, P and Q. These are 2 rings, right? This ring has a radius r1, this ring has a radius r2, and this ring has a moment of inertia I1 about the axis passing, about an axis passing through the center of mass perpendicular to the plane of the ring. This ring has a moment of inertia I2 about the center of mass axis perpendicular to the plane of the ring. It is moment of inertia I1, it is moment of inertia I2. And these 2 rings are made of the same material. I mean, they are maybe copper rings, both of them, maybe they are the rings of steel, both of them, means their density is the same, right? And what is given? I2 by I1 is 4. The moment of inertia of this ring about the center of mass axis divided by moment of inertia of this ring about the center of mass axis is 4. What we have to find? What is R2 by R1? What is the ratio of their radii? इनके radii का क्या ratio है? That is what we have to find. So, okay, What is I1? That is m1 or 1 square. That is what we know. We can't write same mass for both the rings. Although the density is the same, but they are of different radii. They may be, one may be bigger than the other, so mass will be different. What is I2? That is, okay, m2 r2 square. Divide them, divide the two. So I1 by I2 is equal to m1 r1 square by m2 r2 square. It is I1 by I2 is equal to, what is m1? What is mass of this ring? What is mass of this ring? Okay, that is 2 pi r1 circumference length into lambda, mass per unit length, into lambda. Length of the ring into lambda is the mass of the ring, because lambda is mass per unit length. It is m by l, mass per unit length, and r1 square divided by 2 pi r2, yes, lambda r2 square. So it is, what is I1 by I2? Okay, that is R2, I2 by I1 is 4. This ulta ho gaya. So 1 by 4 is equal to, this cancels, lambda cancels. It is R1 cube by R2 cube. And we have to find R2 by R1. So what is R2 cube by R1 cube? इसको मैंने उल्टा कर दिया, इसको भी उल्टा करना पड़ेगा 4. And that implies, what is R2 by R1? That is 4. ये क्यूब जो है, okay, whole cube कर दो. What is R2 by R1? That is 4. ये जो क्यूब है, ये वहां से क्यूब रूट हो जाएगा 1 by 3. Answer. So R2 by R1 is 4 raised to power 1 by 3. Simple one. Let's go to the next problem. This is one more problem that I want to discuss with you. This is a sphere, solid one. This is also a solid sphere. I want to find the moment of inertia of the system of these two spheres. दोनों spheres का moment of inertia मुझे चाहिए. About this axis. About this axis. This is the axis. The moment of inertia is scalar about the principal mass, principal axis. So we don't need to worry about it. We just add the moment of inertia. Moment of inertia is scalar about the principal axis, and we are always dealing with the principal axis. Therefore, there is no problem, and we know there is no problem while adding them. Moment of inertia, total moment of inertia is the sum of the moment of inertia of all the bodies about a particular axis. तो ये axis है, तो मुझे चाहिए moment of inertia इस axis के about इस body का और इस body का together. I want to find the moment of inertia of the system about this axis. उसमें ये body भी आता है और ये body भी आता है. तो देखो, I is equal to, first of all, tell me what is the moment of inertia of this axis, of this body about this axis. इसका radius r by 2 है. तो you know moment of inertia of the sphere होता है I is equal to 2 by 5 mr square. ये है फॉर्मूला हमारा about the diameter axis. जो एक्सिस इसके सेंटर के थ्रू पास करेगा वो डायमीटर के थ्रू ही पास करेगा, और उसका फॉर्मूला ये है. तो व्हाट इज द मोमेंट ऑफ इनर्शिया ऑफ दिस स्फीयर अबाउट दिस एक्सिस? दैट इज 2 by 5 m, that's right, but radius is r by 2, not r, so r by 2 square. Okay, now what is the moment of inertia of this sphere plus, मगर इस स्फीयर का मोमेंट ऑफ इनर्शिया इस एक्सिस के अबाउट नहीं, इस एक्सिस के अबाउट निकालना है. तो इसको लगेगा फॉर्मूला IC प्लस mh स्क्वायर फॉर्मूला, क्योंकि मोमेंट ऑफ इनर्शिया अबाउट दिस पता है लेकिन निकालना है इसके अबाउट. तो इसके लिए ये फॉर्मूला लगाना पड़ेगा, मोमेंट ऑफ इनर्शिया ऑफ दिस स्फीयर अबाउट द सेंटर ऑफ मास एक्सिस प्लस m एंड डिस्टेंस स्क्वायर. तो इसको ऐसे किया जा सकता है, दैट इज 2 by 5 m r स्क्वायर बाय ओके 4 प्लस, चलिए इसका क्या करें, IC मोमेंट ऑफ इनर्शिया ऑफ दिस स्फीयर अबाउट दिस एक्सिस दैट इज 2 by 5 m r by 2 होल स्क्वायर प्लस m इसी का मास, हाउ मच डिस्टेंट इट इज फ्रॉम हियर 2r का होल स्क्वायर. बस moment of inertia of this sphere about this axis is this, but moment of inertia of this sphere about this axis is IC plus mh square. इसका निकालना पड़ेगा इस axis के about. So what is this? I is equal to, okay, तो क्या किया जाए? चलो एम आर स्क्वायर कॉमन ही निकालो आप. एम आर स्क्वायर कॉमन ही नहीं, इनको 2 टाइम्स कर दो. 2 टाइम्स 2/5 एम आर स्क्वायर बाई 4 प्लस एम 4r स्क्वायर. ये 4 और 4 कैंसिल हुआ. ये 5 4 जा 21 एम आर स्क्वायर बाई 5 आंसर. इसको करना पड़ेगा 4 एम आर स्क्वायर और इज एम आर स्क्वायर. चलो मैं करता हूं इसको 2 स्टेप्स में. सो I इज इक्वल टू 1/5 एम आर स्क्वायर प्लस 4 एम आर स्क्वायर. I इक्वल टू 4 5 20 प्लस 1 21 एम आर स्क्वायर बाय 5 आंसर. That is the answer. Now let me go to this for 6th one. Let me go to the 7th problem. This is 7th problem, and the problem is like this. It's a half disk with mass m and a radius r. Only half disk, and we have to find moment of inertia about this axis, making angle theta with its diameter with this line. We have to find moment of inertia about this, making angle theta with the diameter of this half disk. तो क्या किया जाए? तो इसको एक टेक्निक लगाओ और एक हाफ डिस्क यहां से ऐड कर लो. यहां से और एक हाफ डिस्क ऐड कर लो और हो गया ये फुल डिस्क. लेकिन पूरा डिस्क बनना चाहिए, पूरा सिमेट्रिकल डिस्क बनना चाहिए. ये हाफ डिस्क है और मैंने और एक हाफ डिस्क इसमें से इसमें ऐड कर दिया. ठीक है, ऐसे हो गया. सॉरी, ये ऐसे हो गया, पूरा डिस्क बना दिया मैंने. ठीक, तो अगर इस हाफ का मास m है तो इसका भी मास m है. अब मुझे बताइए, ये जो एक्सिस हमारे पास है, isn't this an axis passing through the diameter of the whole disk? It is the axis passing through the diameter of the whole disk, and we can find the moment of inertia about this axis anyway. So what is the moment of inertia of the full disk? That is about the diameter. About the diameter we know of a disk, that is 1/4 mr square. It is the base formula for a moment of inertia of a disk about the diameter axis. About the moment of inertia of the disk about the center of mass axis passing perpendicular to the plane of the disk is 1/2 mr square. But about the diameter axis, it is 1/4 mr square, that I have already discussed. But this m is mass of the whole disk by definition, by formula there, and r is the radius of the disk. But what is the total mass of the disk here? That's I, moment of inertia of this whole disk, not half, whole disk. Moment of inertia of the whole disk. That is 1/4 m/2. Sorry. Not m/2. 2m, because mass of the whole disk is now 2m r square. That is 1/4. Okay, this is the moment of inertia of this whole disk, having mass 2m and radius r. But we had to find the moment of inertia of half the disk. This one, half the disk. This disk, half the disk only. That is I prime. The answer 1/4 2m r square divided by 2. That gets cancelled. So I prime is equal to 1/4 m r square. Answer. So moment of inertia of this part is only, ये जो part है, इसका moment of inertia about this axis is 1/4 m r square. अगर ये axis ऐसे नहीं होता तो ऐसे होता है, same answer. ऐसे होता है, same answer. ऐसे होता है, same answer, same answer, same answer, and same answer even if the axis is like this. So it will not depend on this theta. Theta पर कोई असर ही नहीं है. So I've discussed 7 problems with you, and in the next lecture maybe I will discuss the problems of angular momentum, torque, and conservation of torque. So it will continue, and don't forget to download the app, the Tantra Physics class, and also watch my lectures on YouTube and subscribe to my channel Tantra Physics class. Thank you.